Hello, I'm Pam Hoffman, Everyday Spacer.
And I'm Jeff Miller, 2049 Outfitters. Yeah, that's who I am.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 5 a.m. on Saturday in Germany. We're broadcasting live from Thousand Oaks, California. We'll get to the trivia questions shortly. Right now, though, we are bringing Dawn on with us because she learned more about the comet. Let me share this real quick. This is the whole comet path for the next, almost a month here on this one. And so, Dawn, go ahead and let's see. I got to add you. Hold on. You got a screen to share too, right? There you go.
There we go. Yeah, just updated Astro Stargate about comet Nishimura that was discovered by the amateur astronomer Hideo Nishimura. This is the third comet that he's discovered. I think it's so fantastic. He also discovered C1994 NI, which was named Nakamori Nishimura Mackwitz, and I remember that one. And then in 2021, he discovered comet Nishimura 01. And in addition, he also discovered a nova, which is V6596 Sagittaria. So it must be in Sagittarius.
Wow.
He discovered the comet using a Canon EOS camera, pretty normal digital camera. I'm going to switch over here for a sec.
There he is.
There he is. And here's his comet.
Gosh, that's beautiful.
Very interesting. He's a Japanese amateur, and it's really a really different thing when actual real people discover comets anymore. Usually they're discovered by all these digital surveys and that, but you can see he's got quite the rig here. It would be this is a binocular system. It has 2 cameras on it. And he actually found the comet on pictures. He took pictures. He identified it on August 12th of 2023, but he also had images from the previous night that showed it. And it's a periodic comet, so that's why it has a P. And it also showed up earlier in the year in some Pan-STARRS images, but they did not identify it before his discovery, so he got the credit for it.
Is he based in Japan?
Yes, he's Japanese. It's Kagawaka City. I know that a lot of Japanese astronomers, amateurs astronomers, are really into comet hunting. I don't know if you remember years ago, comet Hyakutake. Made a lot of observations of that one. So this comet is going to be at perihelion on September 17th of this year. Right now, it's in the early morning sky. I've got a finder chart I will show you. I'll show you some interesting things that I found. Go back to my page for a minute. Here's a picture that I got off of Wikipedia. On comet Nishimura, and I'm also going to show you a few pictures of this comet Atlas. They're going to come up. It reached perihelion on July 14th, but it was a pretty bright comet. So
yeah, they keep promising. I hope this one's going to be not Atlas, but this one is going to be a actual comet to look for.
It's interesting. It may I suppose it could break up when it goes around the sun, but because it's a periodic comet, I don't think that it is going to go that close to the sun. I know when it first came out, there were you might see some references to it having a different orbit. At first, they said it had a hyperbolic orbit, but they've turned it into a periodic comet. And it might be associated with a meteor shower called the Sigma Hydrid meteor shower. It occurs in December. I don't know much about that one. So, but I think it was something they identified recently anyway. So it looks like that's been feeding the dust into the
Okay.
that meteor shower. So I'm going to show you a few different things here. Some of the links can be found on my website if you scroll down
that reminds
here.
me. There's your page, and we got some comments. We'll get to those in just a minute, folks.
Okay. Here's
So that's where Dawn has posted her comment page for you to look for.
You want to run some comments through? Say hi to some comments. Say hi to some
Yeah, we can
people.
share. I didn't want to interrupt you, but we got Cliff. Hi, Cliff. Thanks for joining us.
Cliff.
And Scott is also here. We're so glad you're
Hi,
here.
Scott.
Hi, Cliff. Hi, Scott.
Welcome. All right. So you got some more pages with the.
Yeah, some information pages and some really cool pictures. So let's. I'm going to show you this Facebook page first that I found. It is there it is. Sorry. The ICQ Comet Observations. This is the International Comet Quarterly. They are like a clearinghouse for comets internationally. And this site is just, I haven't linked to it, but I think you have one there, Pam, for this too. You could find it on Facebook. It's a public site. You can become a member. You don't have to be a member, but you can look at whatever you want to look here. Some of this was 8 hours ago, so I'm going to go past the ones that aren't. Yeah, here we go. There's Nishimura. It's taken last night. Some really great pictures here. I'm going to go by these. These are an older comet.
Janie says, super share, Dawn. Thanks. And we have someone new.
Hi, Janie.
Welcome, Self-Worth. I hope you put you someday. First time here, no idea what this is about. It's pretty casual. If you have questions, definitely ask. And Dawn's going to share some stuff, and then Jeff and I will share some stuff. We'll do a couple kind of regular things, and then we'll wrap it up. However long it takes is how long it takes. Go ahead, Dawn.
Okay, I'm just going to go through a few of these. I won't go all the way through all of them, but there's some great pictures on here. These are different. There we go. So you can see these. This is where people are actually contributing to this clearinghouse. So you're going to see a lot of good comet pictures in here if you want to keep this in mind. Here's a very nice one.
Yeah, let me put that back up again because that's available to everyone on Facebook.
Yep, you can just go in there and get it.
Yeah,
and I love this one. This is periodic comet 103P, but this galaxy here just blows my mind. That's an amateur.
Oh, that's a galaxy. Wow.
That is NGC 891 in the northern hemisphere. It's a beautiful. This is the time of the year to see 891. It's a beautiful fall galaxy.
Cliff has a comment. Wow, my friend Tom Pickett had a very similar setup when I was there in 2017. I think it was stolen. Oh no! When he went to get a coffee.
Oh,
Twin
that's terrible.
Cameras and fluoride lenses.
Wow.
Interesting.
Wow, that's fantastic.
Sorry about Tom's setup. That's
me too.
Ouch.
So this is a very nice. It's got a lot of different information on here that if you're into this, what else do we got?
Yeah, comets are some of the the things that people are most interested in. Comets, meteors, eclipses.
So it's got this giant round coma and this long tail. It's really fascinating.
Kind of different, huh?
Yeah, I think there's a couple more really good ones. And then there's something specific I want to show. How about that? Look at that tail.
Yeah.
Wow. It's saying here that it has a visual equivalent magnitude of 7.2, which is pretty bright. This is from an observatory in Spain. Pretty bright. I would say that hopefully if it goes around the sun, it's going to be even brighter going back on the way back out.
Oh,
It's got a period of 433 years. So
don't wait for this one.
it's a long period comet. It's
If you
I
want to
think-
see it, go now.
yeah. We won't get another chance. We won't
No.
get another chance. So this is very nice too. So I came upon last night when I was looking at this, I came upon this observation and I was just showing it to Pam and Jeff. I'm going to click over to my other tab. I have it
Yep.
set
And
up
I
here.
think is
This
that
is
this
a
one, the
beautiful-
skylive.com/comments?
Yeah, it's August 26th. So this is, I'd have to keep scrolling through those images, and I didn't want to, I don't want
Yeah,
to drag it all out. But one of the things that I found out looking at this site, we've got, and this is for all you gurus out there. Anyone has an answer for this?
Oh, yeah.
Comet C 2023 P1 Nishimura on 25 UT.
Yeah,
And
what the heck is that?
Astro Man says, what is 25 UT?
Yeah.
And Samora
You're
says,
still on Facebook here, right? The ICQ.
yeah, this is the same thing. This
Okay.
is a log.
Okay.
This is further down in there.
Yeah. And sorry, because I flashed up the skylive.com page.
Oh,
Yeah.
sorry.
One thing I notice about this, a lot of times you'll see a very distinctive blue, and that's the ion trail, right? And the other is the
Yeah.
dust trail. So this
Right.
one doesn't really have that yet.
That one picture, let me flip over here. That one picture, I'll go up here. Boy, did that show. Wow, look at the detail on the tail. So this must be the dust and that must be the ion.
Yeah, if you click on that, I think it'll make it a little bit clearer for us to. Yeah, there we go. Oh, I see.
That image is just,
Oh,
whoa,
yeah.
that is wonderful, wonderful image.
Yeah, that's really nice.
Okay, so anyway, Astro Man asks, what's 25 UT? And I said, yeah, what's that? And he says, he says, I took this picture on August 26th, dawn at Japanese local time, and it was 25th in UT. And Astro Man understands what that means, but I still don't. Because I feel like he said the same thing. Now, what I found was it looked like the day is divided into, like 100 hundredths. So just before midnight, it would be 0.99 or 99 UT.
Yeah.
Local. That's going to be your local time because you notice he says that's local. I don't know. Does anyone else out there have any other ideas about this? Because I was banging my head against this and looking on the web.
Well, we'll crowdsource that, folks. If you got a thought, leave us a comment and we'll share with everybody.
Yeah, I tried my Google foo and I came up with UTC, and it doesn't use just a double digit as part of its.
No, I mean, 25 UT. What time is that?
Yeah.
And there's also universal time, which is like 9 seconds off of UTC. So it doesn't mean that either. So I'm curious, but let's go on and look at some of this other stuff. This is very interesting. It's also linked up on Astra's, this COBS, and it's a comet observation database. And I like this recent observations. This is just, these are the recent observations with magnitude estimates. And if you notice here, this is August 31.15. This is, I think, what that UT is referring to. Here's August 31.15. August 26.96. So I don't know. But anyway, if you come here, there's tons and tons of observations. So we're just going to do a little search.
Are all these clickable links basically, or just the top blue?
These are all of these are. This I think takes you into the thing. Let's go down to this. We'll go into the one. We'll click on our one we want.
And while we're doing that, Cliff did post something briefly recently. Lots of very wide field of views, which I'm setting up my new scope to do. Scope and Canon S5D piggyback on top of scope. I got too much stuff to use.
Oh,
Do you have clear skies though?
Yeah, you got to get those clear skies, Cliff.
That's key.
So I think that's what we're looking at here with that time thing.
Okay.
I think so. This is where you drill into the information. And you'll also notice the other thing that I noticed on here, I shouldn't have done that. I should have stayed where I was. I'm going to scroll all the way up.
You might be on
news. I want to show you the news. Okay. This is the news as of August 18th. And he says, a hyperbolic comet is falling into our solar system.
So is this page the skylive.com/comments?
No, this is this is the COBS. It's an observatory.
Okay.
It's
I
an
did not
observatory. Yeah. Let's get the home. Can I drop it into the comments?
I think so. If you can see the comments.
Yeah.
Well,
should be able to. Yep.
Oh. Tell me if I gotcha. Okay, that's the home page.
Here we go. Yeah, I got it here.
It's the CERNI, CRNI VRH Observatory. It's their page, but they're loaded with these information.
Got it. You got it? Okay.
On their news, they're talking about Nishimura, and they say it's hyperbolic comet.
Yeah, and you said they've decided it was periodic, right?
You look at this date here, and after that, NASA, JPL, they calculated the orbits and everything, and this thing is definitely a periodic comet. Which I thought, well, you're saying it's hyperbolic, but then why does it have a P1 on it? Because that P means periodic.
Got it.
So, but anyway, they found out later that it was actually the periodic. So there's a fella here. His name is Dan Bartlett. Dan Bartlett has a gallery of images.
Oh, that's so beautiful.
And did I mention that other comment yet? Did I mention that, or did I forget to mention it? The one that's on the website.
You haven't told us about Atlas yet.
Okay, well, let's go back to my page quickly. We'll look at Atlas. This is another comet. There's some pictures that we're going to go through of this comet E1 Atlas. It closest approach to Earth was August 18th. And I'll show you its picture here too. It was an astronomy picture of the day on July 14th, 2023. And I have it here, so I don't have to go off. Yeah, and there it is.
Very similar looking with the, like you said, the big glowing.
Coma.
Cliff points out we just had a super blue moon, and it won't happen again until 2037.
Oh, I should flash the blue moon picture then. Let's flash the blue moon picture. I went out of my way. I went on spaceweather.com, and they had this picture of the super blue moon.
Wow.
And Cliff, I wanted to make the comment that around here, when there's a full moon that does anything, it's always cloudy. On the night of the super blue moon, it was totally overcast. Couldn't see a thing. If there's a full moon, if there's an eclipse or any kind of special event, it's always cloudy. If it's a regular full moon, it's just all bright and fills everything, and you can't see anything all night.
And it's a clear night for once in Ohio. I remember that.
Yeah. So here we are in La Giralda, in Spain.
Mm,
This is a famous monument. I don't
mm.
know it, but there you go. There's the blue moon. I finally got to see it on spaceweather.com. And also spaceweather.com. I don't know if it's here. Oh, I was going to talk about space weather always talks about SOHO
Yep.
and the comet observations. And I went out and I found the Everyday Spacer, Citizen Science,
Yeah.
finding SOHO comets.
Yep.
This was 2 years ago, so you can still find comets. I'm having trouble with those two words. And with the SOHO Observatory, they
Yeah,
have
like
found
lots.
4,000 comets have been
Yeah.
found with the SOHO.
Right.
And they also they guess they managed to find the moon on that site, but spaceweather.com is a good place to maybe bookmark.
I guess
So
Cliff said it was perfect, super bright.
yeah,
So he
Prince
finally had a
William,
clear night and it was a full moon.
boy, oh,
I can
bless,
relate.
bless you. I'm gonna go back to this fella who has done he's got a lot of pictures of the comet, and he's got some other pictures in here of
That was
the
beautiful.
Atlas comet as we go through here, but this is what his feed looks like, and you can see he's posted a
Yeah.
lot of stuff.
Wow.
This is a forum. This is I forget what it's called. Let's go down to the bottom here.
Well, it's Astro Bin.
Astrobin. It's
Oh
Astro.
yeah, Astrobin.
Okay, but I've got the close-ups here.
Mm.
So I didn't start at the beginning. I didn't start us over after I showed them off.
Yeah.
Let's go to number
So
one.
was that
It-
one
Here
pretty
we go.
easy for people to find, or was that because I didn't really hear about that? I don't
I
think.
found this through that Facebook page.
Mm-hmm.
They had a link to this to actually Dan Bartlett. He had some postings there, and there was a link going to this site, and that's how I found it.
Mm.
Oh, and look, there's NGC 2504. I think it's a planetary.
Mm.
Planetary. Where is it? Maybe it's a galaxy. So there you go. There's Dan Bartlett's latest. This is his latest.
That's which one is that one?
August 26th. This is the
Atlas or
Nishimura.
Ishimura. Okay.
Yeah.
Cool.
Okay. Most of these will be at first. Okay. This is that ZTF, that one we saw last year, which we also talked about. Not last year. I was talking about it, or you put it out from my website or something. That was the bright comet. Here we go. There's 824, and it's very impressive. I just love that picture. Let's see what else he has. This one, he says, showing considerable activity. It looks like he's got a much clearer sky between here and here.
Mm.
I think he's got better conditions here.
Mm.
Okay, not sure. Now we're looking at Enki. That was that one we were looking at the beginning of that site, Enki. This is a periodic comet. It comes around constantly, like every, I forget, 3 years, 5 years.
Mm-hmm. That's fast.
Another one. Yeah, it's a fast comet. It must be close. Swings by clown face. Do you see the clown face? Is there? There.
Oh,
There it is. There's the clown face. Can I blow it up?
nope, not too
Not
much.
much.
Not enough. I don't know if you guys know what that looks like, but
No.
it's a cool planetary too.
Got it. Okay.
And
Yeah, I haven't
please,
heard
more
that
than
before.
10 minutes on Comet C2023P1. And these are all in like morning twilight. They're all twilight pictures because it's coming up really. Now I like this one. This is at 103. We also saw something about it. I don't know what the ghost of Muroc is. That's beyond me. I don't know what that is, but I think we're coming up on Anki here. I'm not Anki, Atlas. Here's
Yeah.
Atlas.
Okay.
There's Atlas. And there's a couple of them in here. This is Nishimori again.
Hmm.
And then
I think that was where you wanted to end this time.
Jeff. Yeah, I think it is.
Yeah.
It is. Let's see if I get the only other thing I've got to show you. I showed the A-pod, right?
Yes.
The other thing I want to show is this. I've shown it before. This is the Sky Live, and I've put in kind of my address there, my longitude and latitude.
This is the one I have a link for, right? The skylive.com/comments.
Sky Live, yeah.
Oh,
and
good. Okay, there it is.
This is a really great place. There's the Pan Stars. There's the 103 Hartley.
Mm-hmm.
So I have a couple of different things to look at in here, but you put your coordinates in there, and it will
Whoops.
set it up for you. And here we are. This is the finder chart. So this will give you a good idea. I mean, this is set to my location, so the time and everything's going to be for me. But
Yeah.
let's put this on the full screen.
You're really breaking up, Dawn. I don't know what changed, but all of a sudden, you're really breaking up.
Try talking again, Dawn.
I like the full screen version there.
No.
Am I good?
Yeah, we're losing you. No, we're losing you completely.
Yeah,
Like
good video, but the audio is...
Yeah, we're getting a few syllables every now and again. And I think you've shown what you wanted to anyways, right?
Sweet.
Whoops.
Okay, I'm back, aren't I? Am I back?
Almost. But that was the majority of what you wanted to share with us, right?
It is. This is just to show you where it is.
Oh, got it.
Can you hear me?
Still breaking up.
You're still where it is.
I think we need to be done now.
Okay.
Yeah.
Okay. Here. I'm making a second chat.
Okay. Yep. Okay.
Yeah. Let's catch up with you later, Dawn, because it's already 9:30.
Yep.
And we're gonna want. Can you pick? Oh, I see.
Bye, Dawn.
See you. Thanks a lot.
There, that'll make things.
Okay. All right. She says find the comet in Cancer just above Venus. So that's in the morning. Yeah. Mm-hmm. Oh, and Janie came on with what's fabulous shared. Yes. Yes.
Oh, and Cliff says some targets aren't visible from down here, so it's great to see this stuff.
Very good.
Mm-hmm.
All right. Thank you so much, Dawn. Okay. We are so glad you could be with us. All right. So let's see. Last week's trivia question was, what is the coldest known brown dwarf? Mm-hmm. And Jeff has that right here.
Yeah, right here. In 2014, highlight. Okay, that's weird. In 2014, scientists discovered the coldest known brown dwarf called Weiss 0855, using data from NASA's Weiss, which is Wide Field Infrared Survey Explorer mission. This chilly brown dwarf is just about 10 degrees Fahrenheit or minus 23 degrees Celsius, much colder than any other discovered brown dwarf. Because of these temperatures, some have even suspected that the brown dwarf might actually be an exoplanet.
That's wild that a quote star can actually be that cold. Mm-hmm. Wow.
Yeah.
So. Okay. All right. So let's see. Back to us, right? Mm-hmm. Did anyone take a stab at it? We want to have fun with this if it's fun for you. All right. So let's see. We're on to tonight's topic, which is crunchy topics. Brown dwarf discussion. We'll be back in 8.3 seconds. If I can find the button. There we go. good. Yes. Thank you, Dawn. And it was very, very well received. All right. So brown dwarfs are sometimes known as failed stars. They are not massive enough for sustained fusion and are between 13 and 90 times the mass of Jupiter. Let's discuss these objects that are too big to be planets, but too small to be stars. And Jeff will kick off the discussion with some information for you right here.
Okay. Brown dwarfs are basically, they often measure them in Jupiter masses. You'll see an M subscript J a lot. Oh, yeah. And so most brown dwarfs fall between 13 and 80 times the mass of Jupiter. Oddly enough, they're all roughly the same size. Basically 15 to 25% bigger than Jupiter.
Okay. I forget why that was. You were telling me, but I forget.
Okay, yeah.
What's the reasoning there?
The reasoning is the same thing that keeps a white dwarf from becoming a neutron star. Basically, the nuclei.
He's using his hands.
Yeah, the nuclei of the atoms basically repel each other enough to not collapse any farther.
Okay.
So, it's basically as compressed as it can get without becoming a neutron star.
Okay.
And since they don't have the heat to expand, they just have the compressive force.
Okay.
Yeah.
Daniel has joined us. Hi, Daniel. Great Star Tourism. Baby. We're really glad you're here.
Yeah. So even though they run from.
Are you sharing again? Are you looking at the?
Yeah.
Okay.
Yeah.
Here it is.
So yeah, or do a double, but even though they run from 13 to 80 times the size of Jupiter, or the mass of Jupiter, and the way they get the upper and lower bounds of that is essentially fusion starts happening just about 80 times the mass of Jupiter.
Okay.
So that's the upper bound.
Okay.
The lower bound, basically things don't compress enough. And, anything smaller than that is essentially a gas giant.
Okay.
And they generally don't produce a lot of their own energy. Most of the energy coming off of a brown dwarf is the original compression from when it was formed.
Okay. And we do have some more comments. You got a second?
Sure.
Thanks so much for joining us, Stephen Spalding. I think that's the first time we know of you being here. And we have Cliff again. Double feature. I should get a popcorn.
Yeah. So
yes, you should have.
So some of the more massive brown dwarfs do fuse deuterium. Sorry.
Deuterium, okay.
And so there is some fusion going on there, but not enough. It's enough to warm it up some.
Is that the one that kind of?
No.
Okay.
No. And some of them can fuse lithium. The trouble is that they have to have enough of that to actually fuse, because there is no inner or an outer portion of a brown dwarf.
Oh, okay.
So it all convex. So everything mixes. So getting enough of that, because it's not massive enough for the heavy stuff to end up in the center.
Okay.
So since the heat is in the center, heat wants out, so it's constantly convecting. So there's no real buildup.
Okay.
So they're constantly.
And I think that's what helps to fuse it, and then it sparks, and then it becomes a star, right?
Well,
okay.
Yeah, basically, it'll either become a star or not. And once it misses, basically, if there's enough mass, the compression of the original compression of everything clumping together will make it hot enough to fuse.
Okay.
Or there's not enough.
Okay.
Now, brown dwarfs can actually pick up mass if it's in close orbit around another star.
Yeah, like a binary situation. Yeah.
Yeah. Or they found brown dwarfs around a white dwarf.
Mm.
And the only way for that to happen is for the brown dwarf to be there when the original star novas
Mm.
or expands out. And they have one, they saw one that was, must have been within the atmosphere of the red giant when it was in its balloon phase,
Mm-hmm.
and picked up.
You said it survived that.
Yeah, it survived that,
which is
and picked up mass.
Kind of amazing.
And if a brown dwarf picks up enough mass, it does not suddenly light up. It just becomes a heavy brown dwarf.
Okay.
Which is probably one of the reasons.
It just puts on weight, but it doesn't fuse.
Right, because it doesn't have that initial everything coming together compression to light it off.
Okay. Which is how a star forms, basically.
Right. Yeah. And one of the ways that they can tell a brown dwarf from an actual star,
Mm-hmm.
like how can you tell this glowy thing, is it a brown dwarf or is it a, really small star?
Mm-hmm.
Is that if it has lithium in it,
Mm-hmm.
if you pick up spectral lines of lithium,
spectral. You said it was
absorption lines.
Let's see which ones was absorption or.
Yeah.
We just did it.
Yeah. But if it picks up the spectral lines of lithium and it's more than 100 million years old, it's a brown dwarf.
Okay.
Because apparently lithium fuses really easily.
Okay.
And so if it's a star and it's hot enough for fusion, the threshold temperature for lithium is actually lower than hydrogen.
Mm. Oh.
So in a star, the lithium will get fused out, even just being there.
Okay.
It'll fuse with hydrogen and make 2 heliums.
Okay. Huh.
And they go into.
Should I share?
Sure.
Okay.
And these 2 images might look familiar to you as we talked about them. And there's multiple types of brown dwarfs that they talk about, M, L, T, and Y. And they go down in size as the letters go up, and cooler and cooler. There's a lot of...
So a lot of correlations. Okay.
Well, yeah, and there's a lot of, okay, if it's just this edge case, then it's an L. If it's this other edge case, it's a T. And so there's a lot of wiggle room between them.
Okay.
And
Cliff's got a comment. The dwarf would still must be heavy to draw matter from a companion.
Well, if something's giving it off, like in a red giant phase, the red giant is just barely holding on to the outer edges of its matter. So even Jupiter would pull mass from it.
Okay. It's a gravity thing, right? It's a gravitational pull thing.
Right. And brown dwarfs, unlike planets, are formed just like stars.
Mm.
They form an accretion disk. And in fact, they found planets around brown dwarfs.
Mm-hmm.
But as someone asked during our last brown dwarf thing, the Zooniverse, was thinking that it'd be a good place for life. Not really, according to the scientists here, because a brown dwarf is constantly cooling. The habitable zone will get closer and closer and closer.
So it'll sort of...
Yeah, so unless the planet itself is spiraling in, the habitable zone will pass the planet by, probably not long enough for it to, for it to form life. And here was an older trivia question.
And if there is something there, it's going to be very different than anything we know. We know and call.
Right. Yeah. Now, if a brown dwarf is, sure.
Okay.
Now, if a brown dwarf is around another sun, sure, there could be life, just like there could be a life around a moon of a planet. Because if the brown dwarf has a planet, then it could pick up heat from the companion star.
Mm-hmm.
And here's where we talked about a few weeks ago. Brown dwarfs were originally called black dwarfs.
Right.
But, that name was already reserved for a white dwarf that runs out of heat.
Oh, okay.
But considering the fact that the time that it takes even the smallest white dwarf to give off all of its heat is longer than the universe has been around lately so far. We haven't seen any, and we're not likely to see any.
Right.
But the name is still taken up. And they were going to call them red dwarfs, but of course that's taken. And Jill Tartar
Oh yeah, Jill Tartar.
suggested the term brown dwarf using brown as an approximate color, which was wrong, by the way. But
well, because there are a variety of colors, right?
Right. Yeah. Well, she was probably going yellow, orange. What would be darker than that?
Ah,
you know.
Okay.
But so that's where that is. Actually, they found out that brown dwarfs, in the beginning when they're still really hot, look orange to red, to get darker, to then looking somewhat magenta, and then purplish black.
Yeah, you got some pictures in there, right?
Yeah. Deuterium fusion. They talk about some of them have deuterium fusion.
This is just the Wikipedia page, so.
Right. Yeah.
Yeah, if you do a search, you're gonna find this.
And I've got a bunch of other things to show you too, but
cool.
And then class L, class T, and they do talk about them. M's, L's, T's,
yeah, this is good. The HR diagram.
Yeah, red supergiants, red giants, red dwarfs,
brown dwarfs. Okay.
Brown dwarfs down here.
Lower right corner.
Yeah. Yeah. In fact, we saw the image where it did the comparisons, and red dwarf was bigger than a brown dwarf. Here, let's zoom back.
I was going to say, is it it's that one, right?
It's that image right there.
Okay.
Brown dwarf.
Yeah.
Jupiter.
That's a very good image.
Yeah.
I really like that.
Yep. So yeah, they'll be down here, part of this band right here, I suspect. And I mentioned that brown dwarfs are formed like stars, right? Yeah.
Yeah.
Where they have their own accretion disk.
Right.
Yeah. So
yeah, not like planets.
So you won't see a brown dwarf formed around another star unless it's a binary and it was formed as a binary. They would each have their own accretion disk. And basically I think that it has to be a capture because if you think about it, when the star first lights off, it clears the space around itself.
Yes, it does.
And basically stops planet formation.
Yeah. White dwarfs. What does he mean there? Oh, take. Trillions of years to cool a space is a bit of an insulator, not like convectional cooling on Earth. Conventional cooling on Earth.
Exactly. Yeah.
Okay.
So yeah. And that's why things take that's why if you want to plan long term, you build your Dyson sphere around a white dwarf. Nothing's going to be happening to it for trillions of years. Yeah. In fact, they talk about the lithium test.
Back to the.
Yeah.
Okay.
High mass brown dwarfs versus low mass brown dwarfs, but they use the lithium test to distinguish big brown dwarfs from stars. Because again, as I said, if there's lithium, it's not a star.
Oh, it's emission and absorption lines. So let's see, emission lines are
the colored lines. The absorption lines are the black lines in the spectrum.
Yeah. Okay.
Yeah.
There we go. There it is. Oh, there's the purple one.
Yeah. Here's the purple one. Because they can actually have methane in their atmospheres.
Wow.
And further down, it actually explains why there can be methane. Because carbon monoxide when combined with H2 and high heat can break things loose to create methane. But then the methane degenerates back into carbon monoxide because the carbon monoxide and hydrogen is actually more stable than the methane.
Okay.
So it's a constant, creation and mix. And the lower the temperature, the more methane there might be.
Oh, wow.
The higher the temperature, the more likely it is to break back down to carbon monoxide, but it's a continuing cycle.
Okay.
Iron rain. They're about the right temperature
It's hard to think about rain on a star, though.
Yeah, for iron to liquefy out of its vapor.
Jeff, Cliff says not wrong. Energy for millions of years in a Dyson sphere. Yeah.
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 Yeah. I think long term there.
Yeah.
Okay. Low mass brown dwarfs versus high mass planets. And this is where where they get into what's the difference between a planet and a
yeah, and this page is very, very long. As you can see, Jeff is
right
near the top of it still.
Yeah, I'm still right up here.
Yeah. He's thinking there might be a
right.
Maybe.
Yeah, there might be a part 2 to this. We'll but high mass brown dwarfs will be governed by their size would be electron degeneracy pressure. That's the same thing as white dwarfs. Low mass ones will still be the Coulomb pressure as it is in planets. The difference is in Coulomb pressure, the repulsion of the nuclei between two different atoms is high enough to keep them atoms.
Okay.
Electron degeneracy pressure is things are so close that the nuclei are so close together that the electrons are basically free floating in the thing. So it's actually, instead of having big balls of nuclei plus electron repulsing each other, you've got the nuclei kind of repulsing each other because they're both positively charged, but the pressure's enough to put them so close together that the electrons are actually swirling in the mass.
Okay.
And so that's the difference. And then if it gets even more pressure, then the electrons are jammed into the protons and become neutrons, and then you have a neutron star.
Okay.
And more pressure than that. And
is that actual fusion at that point?
No, it's not fusion.
It's not fusion. Okay.
It's no, but there is a lot of energy. I mean, it would make a pretty good bang, I think.
Okay.
But yeah, the changeover from white dwarf to neutron star is probably pretty energetic. Assuming a white dwarf picked up enough mass to actually do that. Usually it happens in the middle of the supernova.
Okay.
So there might be a very brief white dwarf phase in there, but probably not long enough for anyone to notice. But
okay,
that's and they talk about the heat spectrum. Some emit X-rays.
Scott says, ask degeneration.
Yeah. Basically, electron degeneracy. In fact, I have here it is right here. Degenerate matter. That was a link in there. Talks about a Fermi gas, and it when applied to metals.
Wow.
But it's where thermal pressure alone is not enough to avoid gravitational collapse.
Doing the thing.
Yeah, sorry. But like I said, when the nuclei are pressed so close together that the electrons aren't between them, the electrons are kind of orbiting through and in the mix. It's kind of like treating it like a fluid.
Okay. That's really fascinating.
Yeah, and so that's a white dwarf.
I'm gonna have to read this.
Yeah. And the Coulomb pressure is kind of the normal thing. It's what keeps your hand from moving through the table. It's the normal matter stops other matter.
Okay. That's one of the forces, right?
Yeah.
Okay.
But it uses one of the forces. Yeah.
Yeah.
So current standards, they talk about what's the official definitions. And there's sub-brown dwarfs.
Okay.
Objects below 13 Jupiter masses, or planetary mass brown dwarfs.
So they're still stars, but they're smaller.
Right. Yeah. And
Okay.
basically they got created as a star. They had their own accretion disk,
Okay.
and they just ended up being really small. Um, physical properties. This is spectral class M, class T, and if you notice the different colors, class Y, this is all because they're at different temperatures.
Mm-hmm.
Um,
Yeah, that makes perfect sense.
yeah.
I mean, like a really, really hot star is going to be
Yeah.
blue, and an older star is going to be red because it's burnt up a lot of its
Yeah.
fuel. And
Yeah, and if you want to actually see it, and when I talked about methane, the reaction between carbon
there's your
monoxide and
cycle.
methane, here's the cycle right
Mhm.
here.
Okay.
Basically hydroxyls form, and then
Hmm.
and then methane forms, and formaldehyde apparently also, and methanol. Oh, there you go. Suck on a brown dwarf.
Well, there's all kinds of stuff out there. I mean, they've found diamonds and
Yeah.
and alcohol, and isn't there a raspberry
Yeah.
thing out there too?
Well, actually, brown dwarf, if it's a cool brown dwarf, you can get methanol if you don't mind a bit of formaldehyde in with it.
Far out.
The fact that you'd roast your lips off even getting close enough, but hey, more power to you. So they talk about some other things, spectral and atmospheric properties of brown dwarfs. Oh, what? Go ahead.
Cliff says if a white dwarf draws enough matter, it will go supernova and turn into a neutron star. One spoonful as heavy as the moon. White dwarf. Oh, white dwarf. Okay, sorry. I was thinking. Okay. Yes.
Yeah. Yeah. Basically, it can't collapse any farther. I suppose a brown dwarf would do the same thing, but since a brown dwarf is so less massive than a white dwarf, it'd take a lot to do. Chances are real good that anything that could give that much matter to a brown dwarf would eat the brown dwarf. The more massive thing wins.
Mm-hmm.
There's sometimes an outer layer of clouds, but if you look at this, unlike stars, which have these multiple big layers, you get this really thin, like an atmosphere over it. Basically, essentially similar to the atmosphere of the Earth, being such a thin shell.
To think a star would have an atmosphere, I guess they do. But we don't. I don't know that we use the word atmosphere for star.
Well, and
just for a planet.
They don't use it either.
I see.
That's outer layer versus inner layer, except that the inner layer is like 99% of the sucker.
Got it.
99 point something %.
Okay.
And so here are a number. Here, let's show this bigger. These are. This is a red dwarf. This is our son, a red dwarf, and these are the different types of brown dwarfs.
Well, that's the Kelvin. That's the temperature.
Yeah.
Do you remember the names of the different types of? No.
M.
Yeah.
TY, whatever. Okay. But if you notice, they're all roughly the same. This is hotter, so it's a little bit blown up.
Mm-hmm.
But otherwise, once they cool down a bit, they compress here and are almost the size of Jupiter. Almost as small as Jupiter.
Wow. Would they be more massive though?
Oh yeah.
More massive, but similar size.
Because there's, like I said, it's compressed down to essentially white dwarf type material.
Okay.
Just without the heat of a white dwarf.
Okay.
So there's brown dwarfs as X-ray sources, brown dwarfs as radio sources.
Lots to sink your teeth into here.
And if you notice, we're almost getting
halfway.
Halfway, yeah. And they're talking about brown dwarf binaries. Looks like they found one here with a Hubble.
Mm-hmm.
Unusual brown dwarf, white dwarf, brown dwarf binaries. And we'll talk more about that later in some of the other things. Formation and evolution. Essentially forms as a star does.
Mm-hmm.
And can have planets. They've actually found what look like planets around brown dwarfs.
Okay. There's your
Yeah,
artist's impression
of an accretion disk around it. Yeah,
a star forming, basically.
yeah.
Okay.
And it just doesn't have enough mass to actually light off. So that glow is just the heat of the compression.
Okay.
You know, as you compress
not
things,
a fusing
right,
star
right,
forming.
right. But as pressure increases, heat goes up until it radiates out. And you know, since as Cliff mentioned, space is a really good insulator.
Yeah.
They talk about the habitability of planets here, and they talk about, you know, that the habitable zone just zips through it. So
as dense as Thor's hammer.
yeah.
All right. One thing I noticed about the Wikipedia pages, it seems as though when they're scientific like this one, they're pretty good. I know some people have complained to me about trouble with Wikipedia pages, accuracy, data, whatever. But I think that when we find them on the scientific things like this one, they're pretty good usually. And it's like anything. This is a good place to start. You want to triangulate your information from various sources, especially if they do not quote Wikipedia. Janie says, Dwarf Diversity Academy. Thanks, Jeff. Yeah. That's great.
Yeah. And then we're pretty much to the end of the text. They have a bunch of tables of different brown dwarfs. You know, extremes, oldest, youngest, most massive, metal rich, most metal poor, least massive. You know, and so hottest and
Looks
coolest.
like they show where they're located too.
Yeah. Oh, they don't have hottest. I did find
yeah,
hottest. I did find those.
Very warm.
Yeah. So
and we were talking before about can a brown dwarf get enough mass to fuse into a regular kind of star? And you were telling me.
Yeah, they say no.
They say no, but we haven't really seen it. So
right. Yeah. And basically it'll get more and more massive, but it doesn't have the initial compression of all that mass to make it hot enough to light.
Okay.
And so it
seems unlikely.
Yeah. Theoretically, it would just gain more and more mass until it becomes the mass of a white dwarf.
Okay.
But without the heat of a white dwarf. So, you know.
Of course, we keep finding new things. And
right. Yeah. And
who knows what's going to happen for that.
And tomorrow that could be wrong, you know. Yeah.
Red Dwarf, love the show. Yes.
Yes. Yeah. So
I was trying to come up with a quote from it. What's the I forget some of
now the theme song's going through my head.
Is it?
Yeah. But
okay. That's usually me.
Yeah. So we did talk about earlier the coldest brown dwarf. The hottest brown dwarf is
so amazing.
Yeah.
12,000.
12,600 degrees Fahrenheit or 7,000 degrees centigrade.
Now the sun
is 9,900 degrees Fahrenheit or 5,500 degrees centigrade. So it's almost half again as hot as the sun.
But it's still a brown dwarf. It hasn't.
And the way it did that is it's orbiting really tight around a white dwarf, and it's picking up so much heat from the white dwarf that it's just basically
it's a marshmallow.
Yeah, it's a marshmallow.
It's a marshmallow in a fire.
But the odd thing about it is that it's tidally locked to the white dwarf.
Okay. So
the side that's facing the white dwarf is that hot. The side that's facing away from it is half that hot. So
okay.
Yeah.
Marshmallow on fire.
Yeah. I mean, that's just that's kind of neat.
It's amazing. But if it's got like this, well, I don't know, does it kind of curve around does the atmosphere roll it around the outside so it'll even out some, or no? No. Okay.
It just sits there.
All right. Okay.
One side bakes and glows like the Dickens, and
space is wild, man.
Yeah. the brown dwarf orbits so closely to the white dwarf, closer even than Mercury is to the sun.
Good God.
Yes. And if you think about it, a white dwarf is so much smaller than the sun size-wise.
Mm-hmm.
So it's really in there, zipping through,
Jeez.
zipping around.
And it's bigger too, probably, right?
Yeah.
Okay.
Well, white dwarf is not bigger than the sun.
No, brown dwarf is bigger.
Is bigger than Mercury. Oh, yeah.
Well, it's bigger than the white dwarf too, isn't it? Or isn't it?
No.
Okay. All right. So.
No. The white dwarf
Yeah.
has the same compression, but is the mass remnants of a star bigger than the sun.
Right. Yeah. Okay.
So,
Yeah. I'll have to keep straight here.
So, I mean, there's got to be a lot of interesting brown dwarfs out there. You know, we talked about the one that was colder than the freezing temperature of water.
Mm-hmm.
And now they found one that's hotter than the sun. Only because it's being roasted by a really close white dwarf. And that has to be, I can only imagine that it's spiraling in.
Okay.
Because, you know, that's really close.
Mm-hmm. Yeah, it is. You said closer than Mercury, right?
Yeah.
Mercury to our sun.
Yeah.
Wow.
Yeah.
Okay. All right.
So that kind of covers.
Oh, so you think there's gonna be a part 2 or no?
I don't know. I might
through it.
Yeah, I zipped through. I basically blew out a bunch of the math.
Okay.
But in fact, let me get some of these links here for you guys.
Oh, he's gonna share them. I get it.
Yeah.
Okay. I thought he wanted to show you something else, but
No, I'm just gonna
share it in the chat.
share the links. Yeah.
All right, there you
This
go.
is the original. You know, I saw a page that had like, oh, here's some interesting brown dwarf facts, but they were all in the wiki, so I didn't, figure showing that was
Okay.
at all useful.
All right.
And then here is the cold brown dwarf.
Oh, we got another comment too.
Cliff.
Now, kidding, our cats and dogs have been named as the show. Okay, too, and Mr. Lister, our cat's name is now Mr. Rimmer. Passed away years ago. All right, that's from the Red Dwarf show, folks. That's what he's referring to.
They're dead, Dave. They're all dead, Dave.
Oh, there's so many good things about that show.
Yep.
It's fairly quirky, so if you like that kind of thing, yeah, Red Dwarf's for you. All right, so anything else from you on that?
Nope.
Anything else from you on that? We'll watch for your comments, but I do have some stellar events this week. Should we go to that?
Sure.
All right, so we're talking about August 25th through September 1st. September 1st. Since it is the beginning of the month, I would like to tell you about Sky Maps. Let me go set that up. Sky Maps. And if you don't mind sharing.
To stream.
So this is a really great place to come. I would recommend at the beginning of the month, and you want to scroll down just a little bit and look at this link right here. Download the latest issue. It's right under the picture. So when you do that, you will get over to this page, and it shows you what you're going to be grabbing. Although that does say the wrong one. It's a 2-page PDF, and you'll get it right from here. In this case, for the Northern Edition, this download button here. That's for August and July. And if you want different areas, Equatorial Edition or Southern Edition, you just scroll down a little bit further. Yeah, you had comments?
Yep. Good night, Cliff.
Oh, you had nap? See it, Cliff?
Yep, see ya.
All right, so when you go and click on this download button, you get a place to download the PDF. And this one is correct, September 2023, ephemera, cool information. You can read around and around the circle, and there's what's in the sky at certain points in time, because these are static. Planisphere will give you a dynamic version of this kind of thing. But I really like the backside because you can look at these things with naked eye, binoculars, telescopic objects, and I just check them off. I saw that, I saw that, I saw that. a little bit of glossary, and some other things. I really should make this bigger, right?
Right.
Hey, there we go. So you can see that there's lots of good information on here. I usually print them out in one page and the other.
Oh, good night, Don.
Yeah. All right. See you.
Oh. Oh, okay.
No, still watching. Okay. All right. So let's see. And I want to let you know that the Farmer's Almanac, and I think I'm not going to read it tonight because we're so late already, but they have a portion at the very beginning, and it kind of gives you an overview for the month. And there's some really exciting things here. I will read this about Venus. Venus shoots rapidly higher early morning before dawn, reaching its greatest brilliancy of 2023 at mid-month, with a shadow casting magnitude of negative 4.8. All right.
Oh, Jamie, fun learning as always, guys. Thanks. Happy Labor Day weekend. Keep safe in your space.
Likewise. Thanks, Jamie. All right, so let's see. We've got some more stuff here, right? On September 1st to today, the moon is on the equator. Also, Neptune and the moon are in conjunction. September 2nd, Venus is stationary. There's a lot of that happening. You may remember we talked about another planet before that, and there's another one too.
Yeah, we told you what stationary was last week, right?
Right, we read stationary from the Farmer's Almanac.
And you know, I remember there used to be stationary stores. Now there aren't. They're all moving now.
Yeah, okay. September 3rd, moon is at its ascending node. On September 4th, Jupiter and the moon are in conjunction, and Jupiter is stationary. So a lot of this stopping before it goes retrograde or gets back into the regular movement. Also on its Labor Day in the United States and Canada. September 5th, Uranus and the moon are in conjunction, and it's the next globe at night project. And I got some pages to share, Jeff.
Oh, okay.
So here you go, the Globe at Night website. I haven't done this for a while, so I thought I'd check it out. Nice video here if you want to play that. But I'm going to go over here and talk to you about, they say there's 6 easy star hunting steps. During the campaign, go outside, use the Night Sky app on your phone or on the website. You go to this report page, which is coming up. Nope, it's not either, sorry. With a smartphone, you can actually, it'll actually load in the date and everything. You choose your star chart and then choose the amount of cloud cover. And what you're going to look for is in the Northern Hemisphere, you're going to look for Cygnus. In the Southern Hemisphere, they give you a choice between Sagittarius and Grus, whatever.
Yeah.
We haven't figured out how to say that yet.
Oh, and just so you know, some people, Janie and Scott, like my jokes.
Uh-huh. Yeah, well, after 23 years, try and see if you like it still. Anyway, the idea is to go out, take pictures, and report to the site. On September 6th is the last quarter moon, and Mercury is in inferior conjunction. And that's going to be Sun, Mercury, Earth. So they're in a line, and Mercury is between the Sun and the Earth. On September 8th is the Friday night show. I'm doing a profile. Who might it be? Stick around and we'll tell you. Find us on Friday nights at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel. That night also, the moon rides high. Don't say it.
If you or someone you know has done something interesting involving space exploration, science, or astronomy, we'd love to share our live.
Jeff's a little dry. No, they're not.
Join us again next Friday, September 8th. Pam will do a profile of Margaret Hamilton, a NASA software engineer for Apollo.
I got a picture of her.
And that's,
and maybe you recognize this. This is a stack of program items that she wrote herself. It's basically as tall as she is. There's Margaret.
Mm-hmm.
Go ahead. Finish it. Put it in.
Okay. Yeah. Okay, so Margaret Hamilton, a NASA software engineer for Apollo. Tonight's trivia question: what programming language did they use to land Apollo on the moon? Join us again next week and we'll answer and see if you've got it right.
All right.
Let's see, anything else on here?
Anything else from you?
Nope.
We'll watch for your comments as well. And let's give a shout out. Cliff was here. Scott was here. Janie was here. Dawn was here. And she told us about the comment. And we had some new people. Thank you very much for showing up and being with us. That was, let's see if I can find him. Oh, I got Scott here too. Good, good. Let's see. Stephen Spalding. Thank you very much. And
someone who didn't put their own name on.
Yeah, not really a name. It was self-worth. Self-worth.
Hey.
That's okay too.
Yep.
All right. I think we got them all right.
Yep.
Excellent. Thank you so much, folks. We really appreciate you being here.
Mm-hmm.
And have a great week.
Yeah.
We'll talk about Margaret next week on our show. Good night.
Good night.